Alright, let's go. Number 10. Explosive decompression and ebulism. Imagine stepping outside the International Space Station without a pressure suit. The reality of the vacuum is far more gruesome than Hollywood science fiction depicts. It is not an instant freezing process or a dramatic explosion of the body into tiny pieces. Instead, the first thing that kills you is the absolute lack of atmospheric pressure. At the boundary where Earth's atmosphere ends and the void begins, the rules of human biology fundamentally break down. The human body is essentially a pressurized vessel, calibrated over millions of years of evolution for the heavy, comforting blanket of Earth's atmosphere. Take that atmospheric weight away, and the gases inside your body rapidly expand. If you were to hold your breath out of pure instinct, the expanding air would rupture your delicate lung tissue almost instantly, forcing lethal gas bubbles into your bloodstream. But even if you exhaled perfectly to save your lungs, you would immediately face a horrifying physiological phenomenon called ebulism. In a complete vacuum, the boiling point of liquids drops dramatically. The water in your saliva, your tears, and the fluid lining your lungs would begin to boil at your normal body temperature. Your skin would swell rapidly as water vapor formed in your underlying tissues, puffing you up to perhaps twice your normal size. You wouldn't burst like a balloon, thanks to the incredible tensile elasticity of human skin, but the swelling would be agonizing. Within about 10 to 15 seconds, the completely deoxygenated blood would reach your brain, and you would lose consciousness. This is the only mercy of the void, plunging you into darkness before the worst cellular damage occurs. Your heart might stubbornly continue beating for a few minutes, pumping boiling blood through a rapidly failing vascular system. You wouldn't freeze instantly because space is a vacuum, meaning there is no ambient matter to conduct heat away from your body quickly. Instead, you would slowly radiate your body heat away over several hours, eventually becoming a freeze-dried monument drifting in the hostility of the cosmos. The vacuum of space represents the absolute absence of everything we need to survive, a silent, invisible killer that waits mere millimeters beyond the thin metal hulls of our spacecraft. Number 9. Space Adaptation Syndrome and Biological Rebellion. When astronauts first leave Earth's gravity, their bodies undergo a transformation that can be profoundly disturbing. Nearly 80% experience what NASA clinically terms Space Adaptation Syndrome, but what astronauts more bluntly describe as the worst motion sickness imaginable. The symptoms go far beyond mere discomfort, featuring violent nausea, vertigo so severe that up and down lose all meaning, and perhaps most unsettling, visual hallucinations that distort reality itself. The syndrome struck Apollo astronaut Rusty Schweickart so severely that during his 1969 mission, he had to cancel planned activities as he fought waves of nausea. Veteran astronaut Jake Garn's experience was so extreme that NASA created the informal Garn scale to measure space sickness, with one Garn representing the most severe symptoms possible. What makes space adaptation syndrome particularly disturbing is its neurological impact. On Earth, our inner ear fluid helps our brain determine orientation. In microgravity, this system fails catastrophically. The brain, receiving contradictory signals, essentially short circuits, leading some astronauts to report seeing crew members' faces elongate into alien proportions, or watching straight lines bend and warp. But the rebellion of the human body doesn't stop with the nervous system. Astronauts returning from extended missions show bone density loss equivalent to elderly osteoporosis patients. Their muscle mass deteriorates rapidly despite rigorous daily exercise routines. Most alarming are the changes to their cardiovascular systems, where heart muscle weakens, arteries stiffen, and circulation efficiency decreases in patterns identical to advanced aging on Earth. What makes this phenomenon particularly unsettling is its grim implications for long-duration spaceflight. The journey to Mars would require astronauts to spend at least 900 days in deep space. If 6 months in orbit ages the human body by years, what would 3 years do? Every aspect of our biology, from our vestibular system to our visual processing, is profoundly earthbound, turning our own bodies into a lethal liability the further we travel from home. Number 8. The Kessler Syndrome and Orbital Shrapnel. Let's talk about a lethal hazard we have created for ourselves right in our own orbital backyard. Since the dawn of the space age, humanity has been launching rockets, satellites, and probes into orbit, leaving behind a massive trail of mechanical garbage. This isn't just a basic pollution problem. It is a ticking time bomb known as the Kessler Syndrome. Proposed by NASA scientist Donald Kessler in 1978, this terrifying scenario describes a cascading chain reaction of high-speed collisions in low Earth orbit. Imagine a defunct, school bus-sized satellite colliding with a spent rocket stage. The impact, occurring at orbital velocities of over 28,000 kilometers per hour, doesn't just break the objects apart, it vaporizes them and turns the remaining metal into thousands of pieces of hypervelocity shrapnel. A piece of aluminum, the size of a simple marble, traveling at those orbital speeds, hits with the kinetic energy of a falling bowling ball dropped from a skyscraper. These thousands of newly created fragments spread out, creating an expanding cloud of deadly debris that intersects the orbits of other satellites. One collision creates the debris that causes 10 more collisions, which subsequently cause 100 more. Eventually, low Earth orbit becomes an impenetrable cage of flying metal. For an astronaut performing a routine spacewalk, this is an absolute nightmare scenario. Their specialized spacesuits are designed to stop microscopic micrometeorites, but a jagged piece of a destroyed solar panel moving at 20 times the speed of a bullet would tear right through the protective fabric, flesh, and bone, causing catastrophic and instant depressurization. Even inside the heavily shielded International Space Station, crews constantly have to perform evasive orbital maneuvers to dodge known pieces of debris. But we can only accurately track objects larger than a softball. There are millions of fragments smaller than a millimeter that we cannot see, any one of which possesses enough energy to crack a viewing window or sever a vital external cooling line. The Kessler Syndrome isn't just a theoretical hazard. It is an active, escalating threat that could permanently trap humanity on Earth, making space travel entirely impossible and turning the sky above us into a relentless ceiling of deadly, high-speed shrapnel. Number 7. Solar superflares. Our sun, the steady, life-giving star at the center of our solar system, harbors a destructive capability far beyond what most people realize. In 2012, scientists analyzing tree rings discovered the evidence that around 774 CE, Earth was struck by a solar event at least 20 times more powerful than any flare recorded in the modern era. This wasn't an isolated incident, as further research uncovered similar events occurring roughly once every 1,000 years. These solar superflares release energy equivalent to billions of megaton hydrogen bombs detonating simultaneously. The radiation from such an event would be powerful enough to strip away portions of our atmosphere, while the resulting electromagnetic pulse would destroy every electronic device and power grid on the planet's facing side. Satellites would be rendered entirely useless, and astronauts in space would receive lethal radiation doses within a matter of minutes. What makes solar superflares particularly alarming is that our highly dependent technological civilization has never experienced one. In 2012, we had a terrifyingly narrow miss when a coronal mass ejection, comparable to the infamous 1859 Carrington event, passed through Earth's orbit just 1 week after our planet had been in that exact position. Based on stellar observations, astronomers now understand that stars like our Sun can produce flares up to 10,000 times more powerful than anything we've witnessed in the modern era. Analysis of ice cores and ancient tree rings suggests that Earth gets hit by moderately extreme solar events every century or two, while truly catastrophic superflares occur roughly every millennium. The most unsettling aspect isn't just the sheer scale of the damage such an event would cause, but our complete inability to prevent it from happening. Our advanced technological civilization, with all its apparent robustness, exists entirely at the mercy of stellar physics we barely understand and absolutely cannot control. The next civilization-altering flare could begin its journey from the sun's surface at any moment, giving us mere hours to prepare for a sudden and brutal return to a pre-electrical age. Number 6. Galactic cosmic rays. During the Apollo missions, astronauts reported something that NASA initially dismissed, but later confirmed as disturbingly real. With their eyes closed in the absolute darkness of space, astronauts saw flashes of light, brilliant streaks, stars, and luminous clouds appearing in their visual field, despite their eyelids being firmly shut. These weren't psychological hallucinations, but direct evidence of high-energy particles from deep space physically passing through their skulls and interacting directly with their optic nerves or visual cortex. The astronauts were literally seeing lethal radiation with their eyes closed. What makes this phenomenon particularly disturbing is what it represents: the complete and utter inadequacy of our shielding technology against cosmic radiation. These particles, primarily high-energy protons and heavier atomic nuclei accelerated to near light speed by distant cosmic events, possess such extraordinary energy that they pass through spacecraft hulls, spacesuits, helmets, and human tissue. They move through these defenses as if these barriers were barely there, and some particles have been measured with energies millions of times greater than anything our most powerful particle accelerators on Earth can produce. The flashes observed by the Apollo astronauts represent only the particles that happen to intersect with light-sensitive tissues. For each visible flash, countless other particles are passing silently through other body parts, damaging fragile cells and shredding DNA in their path. Outside Earth's protective magnetosphere, astronauts on the International Space Station experience radiation doses equivalent to approximately 1,000 chest X-rays annually. On a future Mars mission, that horrific exposure would more than double. Studies of Apollo astronauts show they have 4 to 5 times higher rates of cardiovascular disease than astronauts who flew only in low Earth orbit. More troubling are the potential cognitive effects, as animal studies showed that similar radiation exposure leads to accelerated brain aging and severe cognitive decline. Current shielding technology remains frustratingly inadequate against these particles. In fact, the interaction between cosmic rays and shield materials can actually produce secondary radiation showers, potentially increasing the astronauts' exposure. As we contemplate longer missions to Mars or beyond, we face the uncomfortable truth of whether humans can survive extended journeys through a cosmos filled with invisible radiation that can penetrate any material we can practically carry into space. Number 5. Rogue black holes. In the vast, seemingly empty darkness between the stars lurk cosmic nomads with the power to tear apart anything that crosses their path. These are rogue black holes, stellar corpses ejected from their home galaxies, now wandering the cosmos with no fixed destination and an insatiable gravitational appetite. Unlike their stationary cousins anchored safely at galactic centers, these gravitational monsters travel at astonishing speeds, some exceeding 1.5 million kilometers per hour. The existence of these wanderers was confirmed in 2022 when astronomers detected a rogue black hole in the Milky Way using gravitational microlensing as it crossed directly in front of a distant star. The black hole's immense gravity briefly bent and magnified the starlight, revealing its terrifying presence despite its invisibility. What made this discovery particularly unsettling is that it was found purely by chance, suggesting countless others remain undetected in the void. When massive stars collapse and explode asymmetrically, the resulting black hole can receive a natal kick, an impulse so powerful it exceeds the gravitational binding force of its host galaxy. Once ejected, the black hole becomes a silent predator, detectable only when actively consuming matter or through the rare gravitational lensing events that betray its position. Astronomers currently estimate that up to 100 million rogue black holes may be silently drifting through our Milky Way galaxy alone. Their trajectories are essentially unpredictable, making them cosmic wildcards capable of completely disrupting any stellar system they approach. A rogue black hole entering our solar system would not need to hit Earth directly to cause a planetary catastrophe. Merely passing through the outer solar system could destabilize planetary orbits and send thousands of comets and asteroids hurtling toward the inner planets. Perhaps most disturbing is their near-perfect invisibility. Unlike stars or galaxies, a solitary black hole emits no light whatsoever. We would have virtually no warning if one was approaching our solar system until it began to gravitationally influence our planetary orbits, spelling the end of our world. How many of these invisible predators are already moving through our galactic neighborhood, and how close is the nearest one to our fragile planetary home? Number 4. Magnetar starquakes. In the cosmic pantheon of extreme objects, nothing rivals the sheer terrifying power of a magnetar. These stellar remnants are a rare and exceptionally violent type of neutron star, already one of the densest objects in the universe, with a mass greater than our sun compressed into a tiny sphere only 20 kilometers across. But what makes magnetars uniquely lethal is their magnetic fields, which are the strongest in the known universe, approximately 1 quadrillion times more powerful than Earth's protective magnetic field. The destructive potential of these objects completely defies human comprehension. A magnetar's magnetic field is so intense that it could erase every credit card on Earth from a distance halfway across the galaxy. If a magnetar magically appeared within 1,000 kilometers of our planet, its magnetic force would tear apart your body atom by atom, as the electrons in your atoms would be violently wrenched away from their nuclei, causing instant tissue dissolution. On December 27, 2004, scientists recorded the terrifying effects of a magnetar eruption when SGR 180620, located 50,000 light-years away, released a burst of energy that briefly outshone the full moon and measurably affected Earth's upper atmosphere. This single burst released more energy in 1/10 of a second than our sun produces in 100,000 years. Had this eruption occurred just 10 light-years from Earth, it would have easily triggered a mass extinction event, stripping our atmosphere away. What makes magnetars particularly frightening to astronomers is their total unpredictability. Their extraordinarily powerful magnetic fields create immense internal strain, causing the star's solid, dense crust to fracture periodically in violent events known as starquakes. These produce random, unpredictable eruptions of gamma rays and X-rays that can sterilize massive regions of surrounding space. Approximately 30 magnetars have been positively identified in our Milky Way galaxy, but many more likely remain undetected due to their sporadic activity patterns. Magnetars represent the absolute extreme of nature's forces, objects so violently powerful that even being in the same stellar neighborhood could spell doom for any civilization. They serve as a stark reminder that in the hierarchy of cosmic power, humanity exists entirely at the mercy of forces we can barely comprehend, let alone control. Number 3. Quasars and relativistic jets. When astronomer Martin Schmidt first identified the faint blue star designated 3C273 in 1963, he realized he was observing something far more extreme, an object so luminous it outshined its entire host galaxy despite being confined to a region smaller than our solar system. This was the first identified quasar, short for quasi-stellar radio source, and it represented a level of violent energy production that astronomers had previously thought impossible. Quasars are powered by supermassive black holes with masses billions of times greater than our Sun, actively devouring surrounding matter at rates that defy human imagination. As this vast material spirals into the black hole's gravity well, it forms an accretion disk, heated to millions of degrees, releasing devastating energy across the entire electromagnetic spectrum. A typical quasar produces more energy than 100 trillion suns while occupying a volume of space not much larger than our solar system, creating a cosmic furnace of almost unimaginable intensity. What makes quasars particularly terrifying to contemplate are the relativistic jets some of them produce, which are highly focused beams of radiation and particles accelerated to near light speed that extend across millions of light years. These colossal jets contain enough pure energy to completely sterilize any galaxy unfortunate enough to lie in their path. The quasar PKS 06377752 produces a jet extending over 1.5 million light-years, making it an unfathomable 5 times longer than the entire Milky Way galaxy. Though most quasars existed in the early chaotic universe, some remain dangerously active today. The closest known active quasar, Markarian 231, lies only 600 million light-years from Earth. Its central black hole consumes the equivalent of 1,000 suns every single year, producing enough radiation to completely destroy any planetary system within hundreds of light years. Quasars remind us that supermassive black holes aren't just passive cosmic drains waiting in the dark. When actively feeding, they become the most luminous and potentially lethal individual objects in the observable universe. What would happen if the dormant supermassive black hole at the center of our own Milky Way galaxy suddenly encountered a rich source of fuel and awakened as a quasar? Would Earth lie directly in the path of its potential jets, or would we merely witness the birth of a brilliant, deadly new cosmic beacon at the heart of our galaxy? Number 2. Gamma ray bursts. In the 1960s, United States military satellites designed exclusively to detect Soviet nuclear explosions began picking up mysterious, blinding bursts of gamma radiation from deep space. These cosmic events, now known to science as gamma ray bursts, represent the absolute most violent and energetic explosions in the universe since the Big Bang itself. A typical gamma ray burst releases more energy in a few seconds than our Sun will produce in its entire 10 billion year lifetime. The source of this extraordinary cosmic power was finally confirmed in the 1990s. GRBs mark the violent birth of black holes. They occur either when a massive dying star collapses at the end of its life, or when two hyperdense neutron stars collide and merge. The energy released during these events is so extreme that it briefly outshines the rest of the visible universe combined. If a GRB occurred in our galaxy and was pointed directly at Earth, it would be visible in broad daylight, appearing as a brilliant flash in the sky before a permanent darkness fell across the planet. What makes GRBs particularly terrifying is their profound sterilizing power. The intense gamma radiation from a burst aimed at Earth from within 3,000 light-years would instantly destroy our ozone layer, exposing the surface to lethal levels of ultraviolet radiation from the sun. Scientific models suggest that even a GRB originating from the other side of our galaxy could trigger a global mass extinction event. Some paleontologists have proposed that the Ordovician extinction event, which wiped out 85% of marine species 440 million years ago, may have been caused by a distant GRB striking our planet. The universe produces approximately one detectable GRB per day, with their distribution appearing entirely random throughout the cosmos. In 2022, astronomers detected a burst nicknamed the Boat, brightest of all time, which originated 2.4 billion light-years away, yet was still powerful enough to measurably disrupt Earth's ionosphere. Had this massive burst occurred within our galaxy, it would have caused an unstoppable global catastrophe. GRBs serve as the universe's cosmic snipers, fully capable of eliminating life across vast interstellar distances with absolutely no warning. Their existence raises a deeply troubling possibility. Perhaps the universe periodically sterilizes habitable worlds through these random bursts of gamma radiation, constantly resetting the clock on biological evolution across entire galactic neighborhoods. Number 1. Vacuum Metastability Event. On July 4, 2012, physicists at CERN announced the monumental discovery of the Higgs boson with a mass of approximately 125 giga-electron volts. Champagne corks popped across the global physics community, but the celebration soon gave way to a deeply unsettling theoretical realization. The measured value suggested our universe might actually exist in what physicists call a false vacuum state, and could inexplicably collapse to a lower energy configuration at any moment, destroying everything that exists. Before the Higgs discovery, physicists had deeply hoped its mass would fall within a specific range, indicating a completely stable vacuum. They expected the universe's quantum state to be at its absolute lowest energy level, much like a ball resting securely at the bottom of a deep valley. This would mean reality as we know it is fundamentally permanent and stable. The Standard Model of particle physics, our most successful theory of fundamental forces, predicted this stability based entirely on the properties of the Higgs field that permeates all of space. Instead, the measured Higgs mass of 125 giga-electron volts places our universe right at the precarious boundary between stability and instability. Physicists describe the situation using the word metastable, meaning our vacuum could be stable for an extraordinarily long time, but isn't fundamentally stable at its core. Think of a ball balanced on a small bump in an otherwise downward-sloping surface. It might stay there for billions of years, but the slightest quantum fluctuation could send it rolling toward a lower state. If this vacuum decay begins anywhere in the universe, it would propagate outward as an expanding sphere traveling at the speed of light. Inside the expanding bubble, the fundamental constants of physics would differ completely, and atoms as we know them couldn't exist. No early warning would be mathematically possible, because the bubble's leading edge moves exactly at light speed. We would be annihilated before any signal could ever reach us to indicate the collapse had begun. The universe would essentially rewrite its own operating system, erasing everything in the process. The precise Higgs mass suggests our universe's existence is extraordinarily precarious, balanced on a quantum knife's edge. Every moment that passes, somewhere in the infinite cosmos, a false vacuum bubble might be forming, expanding toward us at the speed of light, and we would never see it coming until existence itself simply ceased. I'll be sharing more similar videos in the future, so subscribe to stay tuned.